Hello students, in this video we are going to discuss class 9 Cbse Science NCERT textbook. In that we are going to discuss physics chapter 8 motion part 16. We have started with the derivation of equations of motion from the previous videos, and in this video we will be discussing the third equation of motion. Okay, the third equation of motion also called the position velocity relation. The first one is called the velocity time relation. We saw that it is nothing but v is equal to u plus at, and the second equation of motion is the position time relation, which is nothing but s equal to ut plus half at square. And now we are going to do the third equation of motion, which is the position velocity relation. So these are the three equations of motion. These two are completed, and now we will get into this. So before we get into the derivation, as you've discussed in the previous derivations, writing this is mandatorily important. So this is the consideration of the motion of the object to derive the equations of motion. So considering an object having an initial velocity u, which is subjected to a uniform acceleration a, and it reaches a final velocity v in a given time t, and during this motion it is going to cover a distance s. Is it clear? So from that we are able to draw the graph, and we are doing these namings. Okay, so this should be done very carefully as to avoid unnecessary mistakes. Now we will start with the derivation. So already when we looked into the second equation of motion itself, I told you we can stop till one step, that is s equal to ut plus half t into v minus u. Okay, v minus u into t I told you. Okay, but still we will bring till this again. So since it is position, it is nothing but your distance. So your area under AB will give you the distance s, which will be area of the trapezium OABDC, which is nothing but area of a rectangle OADC plus area of the triangle ADB. So S is equal to area of the rectangle is what? OA into OC plus area of triangle B half into AD into BD. So OA into OC, you can very well look into this and write. So it will be what? UT plus half AD is what? T into V minus U. T into V minus U. So till this I told you it is the same for both the second and the third equation of motion. See, look at the name, position velocity relation, but see, have time everywhere. So what we are going to do is we are going to just expand it, and we are going to try eliminating this t. Got it? So I have half and t together. So I have to multiply this v minus u. Okay. So can I write this equation as s is equal to ut plus t by 2 into v minus u? Yes. Now can I substitute for this? So what did I write last? So s equal to ut plus t by 2 into v minus u. So multiplying inside ut plus vt by 2 minus ut by 2. Okay. Let me write vt by 2 separately and then ut together. Ut minus ut by 2. So you have ut common here. Okay. So vt by 2 plus ut into 1 minus 1 by 2. 1 minus half is what? Half, isn't it? So vt by 2 plus ut by 2. So we will get it to be half t by 2 into v plus u. Yes. So for all this, your left hand side is what? S. T by 2 into V plus U. Now again need position velocity relation. So we will try and see what we can substitute for T. So we know that V is equal to U plus AT. So V minus U will be what? AT. So if I want T alone, I can write V minus U by A is equal to T. So this is what I am going to substitute here. Okay. So now see, S is equal to, so instead of T what I am going to substitute? V minus U by A. Okay. So you have T by 2. Okay. So now V minus U by A. So I have already 2 here. I am going to include A with that into V plus U. Got it? So we just take this to the other side. So 2AS is equal to V minus U into V plus U. Is this of the form A plus B, A minus B into A plus B? Yes. So what is the answer we will get? A square minus B square. So this will be V square minus U square. So 2AS is what? V square minus U square. Or sometimes you have to change it, you can change it like V square is equal to U square plus 2AS, and this is the third equation of motion or the position velocity relation. Is it clear? So just go through this now. So area under the VT graph, as I told you, till this step it is the same for both the derivations. Okay, that is the second and the third. Till this step it is going to be the same. After this only it is going to change. Okay, you are going to like multiply everything, and then you are going to bring the T separately, and then you are going to substitute for T as what? V minus U by A. T is what? V minus U by A, and then you are going to get the equation V square minus U square is equal to 2AS, which is called the position velocity relation or the third equation of motion. Is it clear, children? Yes? Okay. So now we have gone through all the 3 derivations. So with this we are completing with the derivations of equations of motion. The first one is what? V is equal to U plus AT. Second one is what? S is equal to UT plus half AT square. And the third one is what? V square is equal to U square plus 2AS. So what is this? V and T. So velocity time relation. And the second one is what? S and T. So it is what? Position time relation. And then this is what? Position velocity relation. Position velocity relation. Hope you understood this, children. We just have one more small concept called uniform circular motion left out in this lesson. Okay, that we'll look into in the next video. If you have any doubts in any of the previous concepts, please get back to the previous parts and then try listening to it so that you will not have any further doubts. See you again other video, children. Thank you, children.